Good morning, everyone. I hope that everyone has stayed safe and warm and has enjoyed the last couple of snow days. We are going to pivot just a little bit and we're going to look at the kind of intro for our next unit. We will still be testing over chapter 4A, so the first half of chapter 4, whenever we come back, which is hopefully tomorrow. But we're going to go ahead and look kind of at the first part of our next unit, which is the second half of chapter 4, just so that we don't get as far behind in our lessons. So you should have already logged on to the Google Classroom assignment, and whenever you open up, it's going to have you make a copy, or it'll create a copy for you of the Google Slides. You're going to follow along in the Google Slides that you have, making the edits as I make them on my slideshow, and then that is what you will submit. So then you'll have a copy of it in your Google Drive, and then I'll also have a handout for you kind of with all of this information whenever we return. But this is also an accountability factor as far as for me to make sure and see who has watched the notes and who hasn't. So we've been going over kind of our basic trig functions. We've looked at just basic angles. We've looked at some right triangle trig stuff. And so now we're going to take those trig functions a step further. The two in particular that we're looking at today are sine and cosine. And just like with our other functions, sine and cosine have graphs. And so we're going to look at how those functions graphs look like, and also how they're a little bit different than some of our other trig functions. One helpful thing, if you have your unit circle handout that we filled in at this point, that would be good to have. Or you can also just Google search unit circle and have that pulled up for yourself as well, because we're going to be referring back to those unit circle values. So either one, pause video, either grab your handout or kind of Google search it and have one up so that you can refer back to it. All right. So on this first page, we're looking at a blank graph. So the first thing that we need to consider when we are graphing trig functions. So remember that for our trig functions, they relate angles and the sides of a triangle. So we are inputting angles and then we get out numbers, which means that when we graph them, we're still going to have inputs, which are x values, and outputs, which are our y values. However, now that those inputs represent angles, and we are mostly going to be dealing in radians, okay, we don't want to label our x-axis as 1, 2, 3, 4, 5, okay? Because then the angles that we have, so remember that they in radians are in terms of pi, and pi is 3.14 stuff. That means that our points would be kind of floating weirdly in the middle between our like tick marks, which is just kind of hard to then graph stuff accurately. But also remember that just like with any coordinate plane, we can change the unit to be whatever we want it to be. And so since we're graphing things in radians, we are going to change them to radians. So up here at the top, I have some of our major unit circle angles. So all of these are your quadrant angles. So just like normal, our origin represents 0, 0. So going to the right, we're going to label these from least to greatest. So we're first going to pull over. Notice that pi over 2 would be our smallest of the ones that we have out there. Next up, notice that we have pi. So we are going to be going by pi's over 2. So that's going to be our unit. So I have pi over 2, then pi is going to be my next tick mark. Then we would have 3 pi over 2, and 2 pi. Now, because we have enough space and these are a little bit squashed right now, again, remember that we can change our units to be whatever we want them to be. I'm going to make every 2 tick marks be my pi over 2, just to kind of spread them out a little bit. So similarly, you need to be editing your Google Slides to represent the same thing. Now that's going to the right. Going to the left, remember that we can rotate both counterclockwise, which is where we get our positive angles, and counterclockwise, which is where we get our negative angles. And we're going to need to graph both positive and negative angles. So going backwards, or to the left, we get those same angles, but they're just negative now instead. So this is going to be the basic template that we're going to use each time. Now, sometimes we might need to adjust what we go by if our graph is bigger or smaller, but for today, we're going to use this going by pi's over 2's for most of the graphs we do. So next up, we need to kind of create our parent function. Remember that your parent function for any graph gives you the basic shape of what it's going to be. We can then apply transformations to that parent graph, but we have to start with a parent graph. So my table is wrong right now. Just gonna fix that real fast. Yours should be correct because I edited the template. If it's not, you can just switch them as well. So remember that our x's in our chart are going to be the things that we're plugging in. So notice there that we have, again, all of those major quadrant angles, as well as we have a couple more. So like pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4 are in there as well. Okay, again, we have a basic graph template here. Okay, so notice that I already have it labeled for you, pi over 2, pi, 3 pi over 2, and so forth. But we do need to fill in this chart because right now we don't know what our parent function looks like. So just like with any function, if I don't know what it looks like, I can make a t-chart, plug in some values, start plotting some points, and then maybe see if I can get kind of a shape to what it's going to look like. So just as always, it's a good place to start at 0. So we're plugging in 0 first, and we're specifically looking at sine. So remember, going back to our unit circle, if I'm looking at my unit circle, remember our ordered pairs are cosine and then sine. So I'm looking at my y values, okay? And those are going to give me the sine for each of my angles that we need. Starting at 0, sine of 0 is going to be 0. So I'm going to fill that in for my first y value, which also means that I can take one of these points and put it at 0, 0 on my graph. As accurate as we can get it. It doesn't have to be perfect, but just so that we get the general idea. So next up in our first quadrant, we're looking at pi over 4. So in our first quadrant, sine is positive. And for pi over 4, it's going to be the square root of 2 over 2. Now notice that we do have the equivalent decimal approximation. We have that because, again, we're going to be graphing this. So grabbing my point, we're looking at pi over 4, which notice is going to be exactly halfway in between 0 and pi over 2. And the reason that we have the decimal approximation is because we know that 0.7 is going to be a little bit more than halfway up until we get to 1, which is what that first tick mark on my y-axis is. So then going to pi over 2, so that's going to be our positive y-axis, or 90 degrees, if it's easier for us to think about it in degrees. And remember that sine is going to be 1 at pi over 2. So then we're going to bring one of my dots. We're at pi over 2 and at 1. Okay. Next up, we're going to 3 pi over 4. So 3 pi over 4 has a reference angle. So notice that my denominator is 4. It has a reference angle of pi over 4. So I should get the same value as I got for pi over 4. And then also remember that sine, being our y value on our unit circle, is also still going to be positive in our second quadrant. So I'm also going to get a positive square root of 2 over 2. So it's going to be a similar placement to our point that we had at pi over 4. Next up, going all the way to our negative x-axis, which is at pi, or 180 degrees. Notice that we will be back to 0 for our sine, or the y value on your unit circle, which means that we are back to our x-axis for sine. Okay. Now moving on to 5 pi over 4, that's going to be in our third quadrant. So remember that in my third quadrant, sine now is negative. And because the reference angle, again, I have a 4 in our denominator, is still pi over 4, I still get that square root of 2 over 2. The only difference now is that it's going to be negative. I'm going to fill in the rest of this chart. So at 3 pi over 2, we will have, again, the same value that we got at pi over 2. It's just now because we're in the bottom, it's going to be negative. At 7 pi over 4, we will also have the same value as our pi over 4, but we're in the fourth quadrant, and sine is negative in our fourth quadrant. And then lastly, circling back all the way to 2 pi, remember that 2 pi is the same thing as 0, so we're back to 0. So now filling in the rest of our values. Notice that we get kind of this like wave-like shape, which is why we can now take this wave-like shape that I have here, and we can try and kind of match these points together. So I'm going to need to expand mine a little bit. Alright, so I've adjusted mine a little bit. It's not perfect, but hopefully we still get the idea that we are connecting all of those dots and that we get kind of this different little wave-like shape. And when we're graphing sine, hopefully we kind of can think about our coterminal angles. So remember that after 2 pi, our angles just continue to repeat themselves, or our values continue to repeat themselves, because remember, I can always subtract 2 pi and get back to an angle that was in our unit circle. And so that's why we get this shape even going backwards. That's going to be very repetitive. And that's what's going to happen after 2 pi. You're just going to keep getting this wave-like shape. And so we really only need, kind of like our unit circle, I only needed to memorize my first quadrant because it was very repetitive. Here, we only need to know our key points. So our first key point is an intercept for sine. Our next key point, notice, is the maximum. So we still have, again, we plotted this point at pi over 4 square root of 2 over 2, but square root of 2 over 2 is not a nice, pretty number. So we don't really classify that as one of our key points. We're just going to stick to the ones that are like very easy to see. So then notice that our next key point is going to be another intercept. I'm going to move this down a little bit just so that we can continue to see. Then we have our minimum value at -1. And then also notice that we are going to end at an intercept as well. So kind of the pattern that our sine graph is going to have is 0. Again, not perfect, but we kind of, again, get the idea of that this curved shape is going to be similar to our sine graph. But we did say that our key points are slightly different. So notice that we start at a maximum. We are also going to end at a maximum this time. Halfway in between is where our minimum is. And then we have our 2 intercepts. So this time our key points go max 0, min 0, max. So slightly different. Notice that we still end and begin at the same type of point. So for our sine, we ended and began at a 0. For our cosine, we end and begin at a max. And then there are always zeros halfway in between any of our mins and our maxes. And that's true for both cosine and sine. Halfway in between your maxes and mins are always going to be your zeros. So that's what our graph of cosine looks like. And there will be a better graph here at the end. So in general, we kind of talked about with sine, but if you notice that cosine is going to be the same. This wavelength type shape is going to continue to repeat itself over and over and over again. And so that's why we can classify sine and cosine as a periodic function. So our definition of a periodic function is that repeats its values after some definite period. Now, for sine and cosine, because we're dealing with a unit circle, and remember that our values that are coterminal, or basically we can always subtract 2 pi or add 2 pi, are going to repeat themselves every 2 pi. And again, that goes for sine and cosine. Now, that doesn't mean that every periodic, or in this case, even trig function is going to have a period of 2 pi, but sine and cosine both do have a period of 2 pi. So kind of to wrap up, again, notice, so that's what I was saying, a little bit better of a graph. So for our sine function, we start at a 0 for our first period. So start at a 0, end at a 0 for 2 pi, and halfway in between we have a 0. So we're a 0, and then we have our max, 0, min, 0. For our cosine, our period is still 2 pi, but we're starting at our max. Then we have our 0, min, 0, max. So on this last slide, I want you to drag next to each graph which one is our sine graph and which one is our cosine graph. It's kind of my way to gauge that you paid attention and that you've kind of understand which one is which. And also having them both here, it's very nice to see. Notice that basically one of our graphs is just shifted over by pi over 2. And then we get the same graph. Then lastly, if you have any questions for me, please feel free to put them into the box here. You can also leave them as a comment on your Google Classroom submission. And I will check those as I go through to grade these. We will also start by me handing out the handouts with your sine and cosine parent graphs on them whenever we come back. And so we can also look over some quick questions then. I hope everyone stays safe in the weather and that I see everybody soon.